All right, this is 2006 problem 1, and it's a question on variability. So 2 parents have each built a toy catapult for the school fair for use in a game at the elementary school because they're competitive and their kid must win. To play the game, students will attempt to launch ping pong balls from the catapults so that the balls land within a 5-centimeter band. A target line will be drawn through the middle of the band, as shown in the figure below. All points on the target line are equidistant from the launching pad. Okay. If a ball lands within the shaded band, the student wins a prize. So basically, if the student gets it within the shaded band, regardless of the arc, they win a prize. The parents have constructed 2 catapults according to slightly different plans. They want to test these catapults before building additional ones. Under identical conditions, the parents launch 40 ping pong balls from each catapult and measure the distance the ball travels before landing. Distance to the nearest centimeter are graphed in the dot plots below. Okay. Now they want us to comment on any similarities and any differences in the 2 distributions of distances traveled by the balls. Well, first off, when I look at that, when they say comment on any similarities or differences, they're asking for me to compare distributions. So when I look at it, it's like, you know what? If I were to fit a curve to this, I go, yeah, not very pretty, but reasonably symmetric for both of them. So I'd say both of them are reasonably symmetric. But what I do notice is this one has a lot more variation, a lot more spread, okay? I also know that the center of this one is about here, and the center of this one, not too far off of it. So here we go. Both are reasonably symmetric. However, the center of catapult B is higher at about 138 versus a catapult A at about 135. And that's an estimate. If you said 136, that would have been fine. Somewhere in there would be good. The biggest difference is the variability in catapult A. Catapult A has both the largest and shortest shots. Catapult A has possible outliers on both sides of the data. Catapult B does not appear to have any outliers. Now, I could have been more specific and talked about the range of each, and that would have been good, but as long as I talked about the spread, I covered it. So I talked about center, I talked about shape, I talked about spread, and I also mentioned that it looks like A has unusual features, whereas B doesn't. Okay, now part B. If parents want to maximize the probability of having the ping pong balls land within the band, which one of the 2 catapults, A or B, would be better to use than the other? Justify your choice. Well, B has less variability, so I know pretty much where it's going, so I'm going to choose B. All right, so smaller variability for catapult B would increase the probability of landing in a given band as soon as the catapult is placed at the right distance. So if I place it in the right place, because it has less variability, I'm going to have a better chance with B than with A. Because even with A, it's all over the place, but B is pretty close. And we have a 5-centimeter band, as long as we hit within 5 centimeters. So part C, using the catapult that you chose in part B, how many centimeters would, from this target line, should this catapult be placed? Well, probably ought to choose the median, which we said was at 138, because this is 136, 137, 138. Because we know 50% of the time it's above that, 50% of the time it's below that. That's probably a pretty good estimate. But let's see if we can put some quantification to it. So we have a 5-centimeter band. So that means if I were at 138, I would still land in the band for all of these, for 140, and all of these. So it turns out that 1, 2, 3 on the low side, and 1, 2, 3, 4, 5, 6, 7 on the high side. So a total of 10 would not have landed in the band. So 10 out of 40 would not have landed in the band, or 30 out of 40 would have landed in the band. So I would place the catapult at 130 centimeters from the target, which happens to be the median. At this value, 75% of ping pong balls landed within the 5-centimeter band, and my child would win their oh so deserved prize. Thank you.